Let us now discuss types of chemical reactions. We have classes of chemical reactions that we discuss in general chemistry, and we're going to do that. The majority of chemical reactions fall into 6 categories. There's combination, that is just what it says, putting together two things to get one new thing. Decomposition, which is breaking apart of one thing to get two new things or two new substances. Single replacement, one element displaces the other one in a relationship. Double replacement, swapping of partners, swapping of husband and wife. Two couple switch. So these are paired, they switch. Okay. Oxidation and reductions, we'll talk about that, also discussed in section 5.4. Acid-base reaction is discussed in chapter 9. Let's start with combination and decomposition. Combination is opposite of decomposition. Combination, you're bringing together two elements or groups of elements to give you one product. Decomposition, you are breaking the single substance to several substances, several particles. So in combination reaction, you are joining two or more reactants to form one product. And an example I can give you is HCl formation from chlorine gas and hydrogen gas. We are combining these two to give us one product. Okay, so generally if you have A reacting with B, you're getting AB combined product, and that's what's shown here in blue. The blues are combining with the greens to give you combination of blue green, blue green, blue green, blue green products. Okay, so two reactants, characteristic of combination, two reactants will end up giving you one product. I gave you an example of Cl2H2. You can also have an example of hydrogen gas and oxygen gas to give you water if it's balanced that way. That's combination. Now if you're going the reverse from the water to the two of them, that would be decomposition, and we can do that by a reaction called electrolysis. So the decomposition is just what I just introduced. If you have your combined product and you break it down to the constituent elements, then you are decomposing. Decomposition is a conversion of a single reactant to two or more products. For example, if I have water and I apply an electric current by electrolysis, I break it down to hydrogen gas and oxygen gas. Let me keep it balanced. Then we have decomposed the water molecule. In this case, A is hydrogen gas, B is oxygen. But anyway, you get your idea. We are just using AB as a general concept. So in conclusion, we are saying decomposition, you're starting with one reactant and you end up with two products. Replacement reactions, there's two of them. There's one that is single replacement and there's double. In single replacement reaction, one element replaces another element in a compound to form a totally different compound and an element that was displaced as products. So if you have A plus BC, you can imagine the A stealing the C away, B will stays by himself, and then you get AC. So you'll have two reactants and you're going to have two products in this case. I give you an example of zinc, solid zinc reacting in or with aqueous HCl. This one, the zinc will take this Cl. You remember zinc is always 2 plus, Cl is minus. So the formula will be ZnCl2. And then the hydrogen is displaced as hydrogen gas. So this zinc would be in aqueous. Okay. So now what we are seeing here is that zinc stole the Cl from the relationship of Cl and hydrogen to form zinc chloride. And then the hydrogen is left single. Okay, so which is why we call this single replacement. You are replacing one thing from a relationship. Let us now explain double replacement or double displacement. Double replacement or double displacement is where there is exchange of spouses. So generally, if you have AB reacting with CD, so AB reacting with CD to give you AD plus CB, there must have been double exchange. So the B took the C in this case, and the A took the D to give you AD. So there's double. It's like two couples swapping husband, wife, husband, wife. Very unethical, but chemicals don't care. So you're still going to have two reactants and two products. So now here you have examples. You have examples of the 4 reactions of replacements. So here I'm looking at sodium picking up the bromine. Sodium picked up the bromine. The chlorine is by himself. So that has to be single. Only one thing was displaced. Ion picking up the sulfate. Ion picking up the sulfate to give you iron sulfate. The copper is displaced. Singly displaced. Okay. Double displacement. Silver takes the chloride to give you silver chloride, and I see the sodium takes the nitrate to give you sodium nitrate. There was swapping of partners, double swapping of partners, so double replacement. Here the hydrogen picks up the OH to give you water, and the sodium picks up the Cl to give you sodium chloride. Double replacement. So those 4 examples show you examples of replacement reactions. Let me show you more examples. Let's look at the first part. I have copper reacting with oxygen to give me one product. Since one product is formed, this is the type of reaction where we say A plus B gives us AB. This is combination. The first one is a combination reaction. We're on the second one. I have water splitting up to hydrogen gas and oxygen gas. So one reactant giving me 2 products. This is decomposition. That's decomposition. Then we are on C. We have Fe solid, ion solid reacting with water to give us hydrogen gas and iron oxide, a type of iron oxide. So it looks like Fe is picking up the oxygen, hydrogen is displaced. This is single replacement. Okay, only hydrogen was kicked out. Then I have AS chloride reacting with dihydrogen sulfide to give you AS sulfide and hydrogen chloride. So here I'm believing that the AS is picking up the sulfur and the hydrogen is picking up the chlorine. So the swapping of partners, this has to be double replacement, complete swapping of partners. On E, I have copper sulfate pentahydrate, one complex compound splitting to copper sulfate and water. It has to be a decomposition, this one. One thing, one substance is split up or broken down to 2 or more, in this case 2. F, I have iron 3 oxide reacting with hydrogen gas. It looks like hydrogen gas is picking up the oxygen to give us water, and the Fe is displaced. So this must be single replacement or single displacement. Okay, here I have calcium carbonate probably being heated to give you calcium oxide and CO2. That's another decomposition. Why? We started with one substance, we are ending up with 2. Here, next, I have iron reacting with the dimer of sulfur 8, two things A and B reacting to give me AB. That one is combination. By the way, the other name for combination is just synthesis. And like I said before, combination is opposite of decomposition. Decomposition, you're breaking what you made. Combination, you're making it. And then I have had dihydrogen sulfide or hydrogen sulfide with potassium hydroxide. It seems to me that the H is combining with OH to give me water. And then the S is combining with the K. See that? The S is combining with the K to give us K sulfate. There is exchange of partners, double replacement is happening here. Next one, I'm starting with sodium chloride to give me sodium by itself, chlorine by itself, decomposition. Starting with one substance that breaks down to two. Here I have aluminum combining with the sulfate. The aluminum is combining with the sulfate to give me aluminum sulfate. Hydrogen gas is displaced by itself. So it's single displacement, or rather single replacement. Only one element was kicked out. Next, I have phosphoric acid giving its hydrogens to OH to give me water. And then I have the ammonium picking up the phosphate to give me ammonium phosphate. This is double replacement because there's swapping, switching, exchanging of partners. Okay, and so on and so on. I think I've done many examples. You get the idea.